want to talk about the round robin algorithm for CPA scheduling with quantum time, different quantum time equal to 2 to 4. So in this case, of course, the round robin algorithm is the preemptive and not non-preemptive because we can get back deallocate the CPU from the process after the quantum time finish. So let's go and see how we can solve the problem using the round robin algorithm. So let's talk about the first example. We want to use the round robin to schedule round robin algorithm to schedule this example. So the quantum time here is 2 nanosecond, as you can see here. So the quantum time is 2 nanoseconds. So at time 0, only one process is in the system already queued. So of course, P1 is a schedule and allocated CPU to it between 0 to 2 because the quantum time is 2. So of course in the queue we have only P1. But between 0 to 2, between 0 to 2 at time 1 and 2, we have P2 and P3 are added in the systems here. So after the P1 got the quantum time 2 nanosecond also, it added to the queue after P3. So after P1, as you can see in the queue, we got the 2 nanosecond as a quantum time to P2, and based on the queue, so between 2 to 4, we got another process here at time 3. So here, P4 is added to the queue, and also P2, after completing to getting the 2 nanosecond, add to the end of the queue here. So till now, we schedule P1 and P2 based on the queue, and now the first in the queue is P3. So we got 2 nanosecond also to P3 here. And after that, new process not coming, so P3 is coming to the queue at the end. So based on the queue, we must allocate the CPU to P1. But because at the first time we got 2, we allocate 2 to the P1, only 1 nanosecond remain. So we allocate CPU for 1 nanosecond between 6 to 7 to P1, and it is completed. So it's not going to end of the queue here. After that, based on the queue, we must assign the CPU to P4. So as you can see, P4 only need 1 nanosecond, is less than 2 nanosecond quantum time. So we assign the CPU to P4 between 7 to 8. It is also completed. Then P2 and P3 also here, we got 1, P2 here 2 nanoseconds, so 2 remained. And P3 also 2 nanosecond, 1 remain. So as you can see, based on the queue, we must assign the CPU to the P2 between 8 to 10, and it's also completed, 2 nanosecond more, and 2 nanosecond is assigned here, so it's also completed. And based on the queue, we only have P3 for 1 nanosecond because only 1 nanosecond here remained of execution of the P3. So we assign the CPU to P3 and the queue is empty now, and scheduling is completed now. We use the round robin scheduling algorithm, and with quantum time 2 nanosecond here. Okay, same as the other algorithm, we have to calculate the waiting time and response time. Sorry, turnaround time. So turnaround time calculated like this. The completion time minus arrival time. So completion time for P1, as you can see here, is 7. So 7 minus arrival time 0. 7 minus 0. After that, we have the P2. P2 is completed on 10. So 10 minus arrival time 1 here. And P3 completed 11 minus 2 as arrival time. And P4 completed as 8, 8 minus arrival time 3. As we can calculate it, 7 minus 0, 7, 10 minus 1, 9, 11 minus 2, 9, and 8 minus 3, 5. So we want to calculate the uh, average turnaround time. So 7 plus 9 plus 9 plus 5, we got 28, and we have 4 processes, so divided by 4, we got 7 as the average turnaround time. And for waiting time, so we have the turnaround time for P1 7, P2 9, P3 9, and P4 9. Just we need to decrease the burst time from them and calculate the waiting time. So 7 minus burst time 3, 9 minus burst time 4, 9 minus burst time 3, and 5 minus burst time 1. So as you can see, we can calculate it. 7 minus 3, 4, 9 minus 4, 5, 9 minus 3, 6, and 5 minus 1, 4. So together we got 19 divided by 4, and the result for average waiting time will be 4.75. In the next example, as you can see here, we have 5 processes and we choose the quantum time 3 nanosecond, also same for round robin. So that the first arrival time, as you can see, 0, you can see, in 0 we got 3 process. So when the arrival time is same as the other algorithm, we put them in the queue based on the priority. Here P1 is the priority 1 highest, then 2, and then 3. So we have P1, P2, and P3. So at the first time, we get the first from the beginning of the queue. So we start with P1 with 3 nanosecond because the QT is 3. So between 0 to 3, another process added to the system we call P4. So P4 also added to the queue here. Then when P1 is completed here, it go because not finished, and now it got only 3, so we need 3 more. So it's going to put here at the end of the queue. So based on the queue, we need to schedule by P2. So P2 got the CPU between 3 to 6, and between 3 to 6, another process P1 is coming to the ready queue, so it's added to the queue here. So after completion of P2, also P2 is added at the end of the queue, like this. So P2 is finished here. So P2 need 2 more. P1 need 3 more. Okay, so as you can see here, P3 got the CPU between 6 to 9, and P3 also after completion added to the end of the queue. So as you can see, P3 need 4 more. After that, based on the queue, at the beginning of the queue, we have P4. So between 9 to 12, the P4 needed 3, and QT also is 3, and after that is finished. So P4 is finished, no need to add to end of the queue also. After that, we need to schedule by P1. So P1 got another, based on here, beginning of the queue, get 3 nanosecond more, and is completed also. So P1 also completed. Till now, P1 and P4 are completed. So now, and the queue is turned off to P5. P5 only need 1 nanosecond, not 3 nanosecond. So we give the CPU only 1 nanosecond to P5 between 15 to 16. So P5 also completed. So now we have only 2 in the queue. So P2 got the CPU for 2 nanosecond because only needed 5 nanosecond is the all the time burst time needed. 3 at the first turn, and now at the second turn got 2 more, and P2 also finish here, and at the end we have the P3. because there is no other process we can get the CPU to P3 until completion, because there is no other process here. So P3 is running between 18 to 22. So as you can see here, we need to calculate the turnaround time, waiting time, and also average turnaround time and waiting time. So now for turnaround time, we need to decrease the arrival time from completion time. Completion time for P1, as you can see here, is 15. For P2, completion time is 18. For P3, completion time is 22. For P4, completion time is 12. And for P5, completion time is 16. So arrival time for first P1 to P3 is 0. For P4 is 2 and P5 is 4. So for the P1, we got 15 minus 0 because P1 is completed as 15, arrival time 0. P2 completed as 18, so 18 minus 0, also arrival time same. The P3 completed at 22, 22 minus 0, arrival time is 0. Plus P4 completion time is 12. 12, you can see here, minus the arrival time is 2. So 12 minus 2 is for P4, and 16 completion time as P5 minus 4 arrival time. So we have 15, 15 minus 0, 18, 18 minus 0, 12, 22, 22 minus 0, 12 minus 2 we got 10, and 16 minus 4 we got 12. So some of them are 77, and we got 5 process, so average could be 15.4. And about the waiting time, we have the turnaround time. So we got 15 for P1, 18 P2, 22 P3, and 10 for P4, and 12 for P5. In this case, we must decrease the burst time. Burst time for first P1 is 6, P2 5, P3 7, P4 3, and P5 1. So we got 9 plus 13 plus 15 plus 7 plus 1, 11. The total is 55, and we got 5 process. The average would be 11 in this example. Okay, another example. Also, we have 5 process, and quantum time here is 4 nanoseconds, as you can see. So we will start in arrival time 0. We only have P1. So we add the P1 in the queue and schedule P1 here between 0 to 3. So because why we use only 0 to 3, as you can see here, because the burst time for P1 only 3 is less than 4 nanoseconds, so it got only 3. So after that, between 0 to 3, we have P2, P3, and P4 here in the queue. So next process will be P2 based on the queue, as you know here. So P1 is completed. P1 is completed here. So now P2 got the CPU for 4 nanoseconds. So 4 more remain. So based on the queue, after 4 remain, it's between 3 to 7, we got new process P5 added to queue here. And after completion of the quantum time for the P2 added to queue also after P5, because P5 is on 4 and completion time is 7. So as you can see here, the next in the queue is P3. So P3 got the CPU between 7 to 11, so 4 is executed and 3 more needed. So P3 is completed here and then added to the end of the queue after P2. So the next one in the queue is the P4. So P4 got the CPU between 11 to 15. So from 5 we need 1 nanosecond more. After P4 also added to the end of the queue here, and the next here is the P5. P5 only need 2 nanoseconds, which is less than 4 nanoseconds. So only give the 2 nanoseconds to the P5 between 15 to 17. And then also P5 is completed. No need to add to end of the queue. So now in queue, we have only 3 more process. So based on the queue, we assign the CPU to the P2 for 4 nanosecond, same as this, and it's also finished here. So as you can see, it's finished on 21. So after P2, the turn is going for P3. So P3 got the CPU only 3 nanosecond because only 3 remained, and 3 is less than the quantum time. So it got the CPU for 3 nanosecond and only one P4 needed, and only 1 nanosecond needed to complete the P4. So between 24 to 25, CPU allocated to P4. So let's start to calculate turnaround time and waiting time. So turnaround time for this, completion time of P1 is 3, completion of the P2 is 21, completion time of P3 is 24, completion time as P4 is 25, and completion time of the P5 is 17. So we need to put them here: 3, 21 for P2, 24 for P3, and 25 for P4, and also 17 for P5. And the arrival time is 01134. So 01134. So we calculated and we got 81 divided by 5, because we have 5 process, and the turnaround time, average turnaround time here will be 16.2. For waiting time, we have this turnaround time, and we must decrease the burst time, CPU burst time from them. So for P1, 3, burst time also 3, 3 minus 3, 0. The next one, 20, 20 minus the burst time, 8. So waiting time would be 12. The next one, 23 minus burst time, 7. So 23 minus 7, 16. The next one, 22 minus 5. So 22 minus 5, we got 17. And at the end, the turnaround time for P5 is 13 minus 2 burst time, we got 11. So some of them, we got 56 for 5 process divided by 5, and we got the average wait time 11.2. Okay, thank you very much for watching my video, and please support us with subscribe, like, and also comment, and also introducing this video to your friends. Thank you very much.